Assalamualaikum and good morning, everyone.
Salam sir. Good morning.
Okay, so uh, what a long holiday because we don't have class last week. So I hope you still know how to use Matlab. Okay, so we continue with our lectures with a new topic. So today we are going to look at how to use Matlab on solving ODE based model. Okay, so ODE, as you all know, it's ordinary differential equations, one of mathematics subjects that you have taken maybe during your first or second year. Okay, so in this lecture, you guys should be able to understand the application of ODE in modeling a biomechanics system and also solve and analyze various ODE models of biomechanics using Matlab. Okay, so ODE is an equation that is written in terms of an unknown function and its derivative. Okay, so ODE will have derivatives with respect to a single dependent variable. So maybe in AC, okay, in AC you have learned about ODE that dependent with time. Okay, for example, like finding a displacement. Maybe you are familiar with this kind of things. Okay, familiar with this in subject like AC, automatic control, or finite element method. So here, the box is connected with a spring and has a mass m. And we want, actually we want to find the displacement of this point. Okay, so the equation that describe the displacement of this point can be in the form of ODE shown here. So here, because the displacement x is differentiated with time, so we call it ODE or differential equation. And the order of ODE, the order is basically the highest power of the derivative in that equation. So here we have d2x dt squared. So because 2 is the highest derivative or highest power of derivative, then the ODE is second order. If you have 3 here, then the ODE is third order and so on. And you also have learned about ODE in system. Okay? So system of ODE basically has many equations that you must solve simultaneously. So for example, you have dx1 dt, dx2 dt, dxn dt, and so on. So you probably found this in subjects like automatic control and finite element method, where you solve this simultaneously. So to solve an ODE, you need to have initial conditions. So usually you will be given initial conditions to solve an ODE. So if you are not given initial condition, so you cannot solve ODE. Okay. So the initial conditions are the value of the variable, for example, x at time 0. Okay. So at time 0, what is the value of x? So here, the value of x at time 0 is given as 1. And the value of the derivative x, the derivative of x at time 0 equals 1. Okay. So this is an example. Okay. Example of initial conditions. Okay, so let's look at an example of first order model. So first order meaning that the equation, the derivative, the power is 1, okay, the highest power. So the most common first order model in biomechanics is called population growth model. Okay, so we have like dn over dt equals rn times k minus n over n. Okay, so if you solve this manually and plot the graph, you get a graph shown here. Okay, so the purpose of this lecture is to solve ODE in Matlab. Okay, so in subjects like ODE and AC finite element, you solve ODE using integration method, meaning that you solve it manually by hands. So the method of solving ODE by integration, we call it to find the exact solution. Okay, the solution of the equation in its exact form. Okay, exactly. But if you use Matlab or numerical methods, you are not finding the solution, or you are not finding the exact solution, but you are finding an approximate solution. Okay, which is the solution is approximately correct, okay, to the actual one. So in Matlab, there are so many functions that are specifically to solve, specifically used to solve ODE. Okay, so we are going to look at what are these functions and how to write a code to solve ODE in Matlab. So to solve ODE in Matlab, you need two functions. Okay, you need to write two functions in your Matlab. So the first function consists of ODE equations. So you will need to write all your equations in Matlab in the first function. And then in the second function, you need to write the solver. Okay, so always remember to solve ODE in Matlab, you need to have two functions. Function one for the ODE equations, and function number two is to write the solver. Okay, so let's look at an example. So let's say you have a single ODE equations. Okay, so given an ODE shown here with the following parameters and initial conditions. So here the ODE is dy dt. So y is the variable that you want to solve. So you have alpha y minus gamma y squared. So alpha and gamma are the parameters. Okay, so don't mix between the variable you want to solve, which is y, and also alpha and gamma. So alpha and gamma are the parameters. So usually alpha and gamma are given, and the y here are not given. So you need to find y by solving in Matlab or solving manually. So here the initial condition given, the value of y at time 0 equals 10. And then you want to solve the model for time span or for time range from 0 until 9 seconds. Okay, so to solve ODE in Matlab, you need these informations: the equation, the initial condition, the parameters, the values of the parameter if there are parameters, and the time span. Okay, the time span that you want to solve the equation. So to solve that ODE, first you need to write the function at the bottom here, function number one, which is containing all the ODE equation. So first you write the ODE. So let's say you write dy dt equals, so alpha, maybe you represent by a, alpha times y, minus gamma, maybe you represent by symbol g, times y, okay? Because here y squared. So you can either write y squared or y times y. It should be the same. And then you define the value of a and gamma and g. So a equals 2 and g equals 0.0001. Okay, so when you have this in your ODE, in your function, then you name your function as any name. So try one here is the name of the function. So you can put names, any name that you want. Okay, so this is the name of the function. And in that function must receive two inputs. Okay, so the first input is time, and the second input is y. Okay, so this y here must be the same with this y. So if you write x here, so this must be x. Okay, and the function must send an output, the dy dt. So if you write dy dt, here also must be dy dt. So let's say if you write dx dt here, then here must be dx dt. Okay, so the first function you need to write is function that consists of ODE equation, and you write it at the bottom, okay, or before the function number 2. So usually you will write this function first in Matlab. Okay, so this is the equation, and you write the equation in the function. Okay, and then define the parameters. Okay, next you need to write the second function. So you need to write the second function on top of the first function Okay. So in the second function, you need to have the time span and also the initial condition. Okay, so you need to write these two things first. So time span. So from the question, the question asks you to solve the model from time 0 until time 9 second. So you just write from 0 until 9, okay, in square bracket. And then the initial condition, maybe you name it as y naught equals 10. Okay, so the value of y at time 0 equals 10. And then after you have your time span and initial condition, then you need to write the solver. Okay, so look at the solver. So the solver here, you must write it like this. Okay, so the output is t and y, big T and big Y, in a square bracket equals ODE 15S. So this is a solver in Matlab. So this is a built-in function in Matlab. And then in this function, you must have three things. So the first thing is you call the function that contains the ODE, which is function number 1. So here, add symbol add try 1, meaning that you call this function try 1 here. So if you name your function, let's say try2, for example, so here you must write add try2. Okay, so the first part here is calling the function. And then the second part, or the second component of the ODE 15S is the time span. Okay, so it will use this time span value and solve the ODE. And then lastly is the initial condition. So it will use the initial condition you wrote here to solve the ODE. So you must remember that in the solver must contains three things: the name of the ODE function, which is this function, and then the time span, and then the initial condition. So let's try write this in Matlab and see what happened. Okay, so in your Matlab, you just open a new script or new here, any one of this will work. New script. So you write your function ODE, okay? Function dy dt equals the name of your function, and the input must be accepting t and y. So after that, you write your ODE. So your ODE is given as A times Y minus gamma times Y squared. Okay, so the important things that you need to do first is to write your ODE. Okay, so later maybe when you do assignment ke, so the first thing is to write your ODE. And then after you write your ODE, then you define all the parameter and its value. So A is equals to G equals 0.0001. Okay, make sure everything is there, then this function is okay. Then you write your second function. Okay, so your second function should have the same form, okay? dy bracket, square bracket, and then you name your solver function. So usually I will use the same name try1, but add something to make it different with this try1, maybe solver try1, for example. Okay, so it doesn't accepting any input. Okay, so when you save your ODE, your function here, this editor, so make sure that you save um, your file using this name solver underscore try1. So if you save it using different name, then your code is maybe correct, but you cannot run your code. Okay, so you must make sure that it is saved using the same name of the function number 2 here. Okay, so after you save it here in the current folder, don't change this anymore. Okay, jangan tiba-tiba separuh jalan tukar to delete R ke, so it won't work. Okay, so make sure that this is the same with the file that you save .m here. Okay, so in function number 2, you first write your time span. So time span from time 0 until 9. And then your initial condition, which is equals 10. And then you write your ODE solver. Okay, so we use ODE 15S. So this is one of the solver in Matlab. So the first component is you must call the function number 1. So just write add try1. So it will automatically search for try1 function. And then the second component is the time span. And the last component is why not. Okay, so let's try save this and run. Okay, so when you run, you will get an answer here. So the answer here represent the value of y. So you can plot the value of y against time. Okay. Okay, so the best way is to run this code is not using this run. Okay, so the best way is to copy this and put it in the command window and just press enter. So here you will get your variable t and y. So basically what happened is that you will get your solution for y and the time range, okay, for the solution. Okay, then you can plot. Okay, so in the slide, basically it plots y versus t. Okay, plot y versus t. Okay, so let's run the code again. Okay, so you get a graph. Okay, so I hope you understand the basic concept of writing ODE solver in Matlab. So let's continue with the slide. Okay. Okay, so just now I explained about the ODE 15S as a function or built-in function in Matlab. So there are many more ODE solvers in Matlab. So you have ODE 45, ODE 23, ODE 113. So all of them has a specific functionality. Okay? And for example, if you cannot use 15S, you can try 45 or 23 and so on. This is usually used by those who use solvers that solving equation that are very difficult to solve. So maybe if you use 15S, then you didn't get the solution after a few hours. So maybe you can try change to 45 and so on. Okay. So there are many more solvers, but the most commonly used is 15S because dia macam somewhere in between lah, bagus dengan tak bagus. So the basic one yang paling pertama sekali is ODE 45. And then if 45 cannot work, then use 15S. But for me, I will just use 15S. Okay, 45 pun boleh je. Okay, so after you run the code as I shown previously, then you can do some analysis or plotting. Okay, so in this example, you plot y versus t, and if you have a system of ODE, then you will have more than one y. Okay, so here y dot double dot comma 1 represent the first y. So in this example, you have only one y, so you don't need to write this double dot comma 1. But later in the next example, you will see why you need to write this 1 and so on. So the general procedure, first you define the ODE function. So you write the ODE function, and then you write the ODE equations in that function as well, and defining all the parameters. And then the next step is to define the time span, define the initial value, and then choose appropriate ODE solver. And all of this you must write in another function, and save that function using a name that's similar to that function. Okay. So example just now, I write solver underscore try 1. So make sure the name is the same. And then you run solve 1, run the function number 2, or function number 1, function number 2, mana-mana lah, function yang atas. And then you can analyze the results, plotting graph, calculate rate, and so on. Okay, so let's look at another example of system of ODEs. So the most common example of equation in biomechanics is called Van der Pol equations. So in dynamics, the Van der Pol oscillator is a non-conservative oscillator with non-linear spring. So basically, Van der Pol equation describe the oscillating things that oscillates. Okay, so the common application of Van der Pol equation is to describe the action potential in neuron. So action potential is basically the electrical current in our muscle. Okay, so electrical current in our muscle or in our brain is submitted or is transmitted using neurons. So there's an action potential, or potential ni V lah, apa dalam bahasa Melayu tak ingat dah, electric potential lah. Okay. So Van der Pol equations in relaxation oscillation has two equations. So the first one is dy1 dt equals y2, and the second one is dy2 over dt equals 1000 times 1 minus y1 squared times y2 minus y1. And then usually the initial condition is y1 at time 0 equals 0 and y2 at time 0 equals 1. Okay, so to simulate this system, first you need to create the function ODE, the ODE function. Okay, so here in this example, the function is named as OSC, okay, OSC, that contains all the equations. Okay, so first you define the equation dy1 dt equals y2. Okay, so in the ODE function, so here dy dt is the output. So because we have two ODE, so to differentiate between the first and second ODE, so the first ODE we write dy dt bracket 1. Okay, so represent dy1 dt equals y2. So y2, to write y2, you just write y bracket 2. Okay, so y bracket 2 represent y2. And then the second equation dy2 dt, so we just write dy dt bracket 2 equals 1000 times 1 minus y1 squared. So y bracket 1 squared times y bracket 2 minus y bracket 1. Okay, so y2 represent y bracket 2 represent y2, y bracket 1 represent y1. So dy dt bracket 1 is dy1 dt, dy dt2 is dy2 dt. Okay, so the first syntax here, the first line or line number 2 here, dy dt 0 to 1. The purpose of writing this is to create an empty column. Okay, so this is I would say just write, okay, just tulis je. Kalau ada 3 ODE, so it becomes dy3 zeros d zeros 32 31. Pakai mouse susah. Okay. So dekat sini ada 2 ODE, so you write zeros 21. So just tulis benda ni sebab the purpose of this line of code is something like I would say like a precaution, macam sebab bila when the ODE when Matlab solves the ODE, dia akan macam guna function ni iterating banyak kali. So programming language they tend to get crazy when the function is used multiple times. So to put this 0 to ensure that the variable is clean ataupun dibersihkan. Kalau tak bersih, dia akan mix the numbers. So when you get your result, result macam salah, tak sama dengan yang sebenarnya. So the purpose of this line is to ensure that the values you get is new, okay? Tak tercampur dengan values yang sebelumnya. Okay, and then after you write the ODE equation in a function, then you can write the function, the solver function. So same concept, ty, and then you write an extra name. So OSC, here you write call or solver or anything else. And you save your function using this name. So you write the time span. So time span given from 0 to 3000. And then disebabkan ada dua y1 and y2, so you need to write two initial conditions or two initial values. So y1 naught equals 2 and y2 naught equals 0. And then this you can combine them in a square bracket. Or you can simply write y equals square bracket yang ada benda ni. And you just write here as y, okay? So any cara, it should produce the same results. And then you write the ODE solver, call the function ODE, write the time span. And then you can plot whatever that you want. So because you have two y, you have y1 and y2, so you can use this to plot which y that you want. So here, they plot y1. So if you want y2, just replace this value with number 2. So here the result for y1. So dia dapat macam something yang berulang, oscillating. Macam sine function tapi dia square. Tak berapa square, trapezium kot. Oh, dah habis. Okay, any question before we end this lecture? Any question regarding your assignment? Ke dah siap?
Yes, sir.
Tak payah discuss lah assignment.
No, sir.
Oh,
No.
assignment 1, 1A and 1B, 2 markah, so ada 4 markah. So kalau hilang pun okey je.
No, sir. No, sir. No.
Apa tu? Carut apa? Tiba. Tak clear, tak clear.
Sekejap.
Mana tadi? Ni. Okay, so question 1 ni, you need to write a function, okay? That's why dia cakap kat sini, create a function. So maybe you can start by writing a function, macam mana ni ya? Or maybe you can start by answer question A. So question A is straightforward je, okay? So just tulis apa yang dia nak. Dah, okay? So when you run this code, let's say run assignment 1. So kita akan dapat value of x. Ada 200 value of x that is randomly selected by the function, okay? So after you write this, then you can write question number 2. So create a function y, which has the following relationship. So write function, maybe return y, maybe nama dia function y. So accepting x value. Okay. So dia akan terima value x. Bila kita hantar x, dia akan kira x, let's say x, value x yang pertama, let's say 0.4025 for example. So dia akan ambil value tu and then dia kira sama ada sin x ataupun x squared plus x. So ni syarat dia, kalau nak sinc x ni, dia akan cari element in x that are odd in position. So what does that mean? So let's look at x. So x yang pertama ni, negative 0.4025, it's on odd position sebab dia dekat posisi nombor 1. So yang kedua ni, negative 0.2215, it's in the even position sebab dia position number 2. So ni odd, ni even, ni odd, even, and so on. Macam nak buat? Google. Macam mana nak buat? Google. Okay, sila Google. So dekat Google memang ada dah macam mana nak cari odd position, even position. Okay. So subjek Matlab ni, subjek saya ni, kita Google. Okay, tak tahu Google. Senang je.
Betul.
Ah,
Yang
sabar
yang
jangan gelak.
yang sainsi tu lah.
Sorry, sainsi.
Ya, tu dia kalau dia tak perlu letak ke dekat yang function y.
Perlulah kena ada if something,
Bukan.
y sama dengan sainsi macam tu.
Oh. Dia warna merah kalau apa macam ada error lah kalau buat tu.
Ni okey je.
Tak. Dia tak lengkap nak install tu Ada benda yang nak kena selain Matlab tu mungkin.
Tak adalah sainsi ni common je. Sepatutnya common je sainsi.
Common je.
Kalau tak ada, awak letak sign je lah. Okay? Ni just nak bagi korang try je. Okay? Nak bagi korang explore Matlab. Okay? Kalau tak boleh, letaklah sign H ke. Sains ni common. Saya tak tahu apa benda. Saya Google ada. Okay, itu je saya pakai.
Okay. Google
And then question C pun sama. Function Z. Function namakan dia. Setting X. And so yang ni mungkin straightforward sikit. So if X less than -1, 0.1 or pakai ni and so on. Else, if, else. Tu letaklah value Z dia apa. Ni question C ni should be orang boleh buat. Okay? Question 1 ni kena fikir sikit macam mana nak cari odd position, even position. Okay, after you write all of this, okay, then you write you answer question D using the function B and C and the values of X created in A, determine YX and ZX. So X tadi ada 200 elemen. So bila kira Y dan Z, they should have 200 elements as well. Okay. So bila kira tu make sure Y and Z has 200 elements. So I think this part might need to use for loop. Or maybe not use for loop. Okay, ada banyak cara. So soalan ni soalan test tahun bila 2 tahun lepas kot. So some of the students managed to find pakai for loop, ada yang tak payah pakai for loop, so they Google. Okay? So dia orang ada banyak jawapan. And then you can plot the results. Ada boleh kena letak labels and legends. Okay? So this is you need to explore how to plot with labels and legend. Okay, simple je soalan dia. Ada assignment 1B. So assignment 1B should be slightly difficult sikit. So yang ni kena refer tutorial YouTube. Macam mana nak buat yang hari tu kita discuss yang saya tak dapat tulis ikut kod dia. Tapi kod dia saya dah upload it in Kalam. So you should be able to write this code based on the code that I posted in Kalam. Okay, but question number 1, you need to plot. Okay, plot the signals and do the label and so on. Question number 4 ni kena berfikir sikit lah. So ni requires you to think how to analyze the results. Okay, so yang ni tak dapat lah tolong. Ni just based on your opinion. Okay, so that's why question in your opinion. Okay, so opinion dalam exam, opinion tu kena betul lah. Kalau opinion tu salah, tolak markah. So walaupun dia opinion, tapi disebabkan exam, kalau sebabkan dia soalan assignment ke exam ke, dia jadi opinion yang kena betul. Tak boleh opinion salah. Macam tu lah. Okay, so I hope you can try this. The purpose of this assignment is to make sure you tahu nak tulis Matlab. Okay, maybe it will be beneficial if you for your FYP ke. Okay, maybe beneficial for your FYP. Okay, siapa yang FYP ada guna Matlab. So kalau tak guna Matlab, maybe beneficial, tak tahulah, beneficial untuk masa depan ke. Okay, so I will post it to these lectures in YouTube. And if you have any question regarding the assignment, just ask me, okay? So that's it for today. Thank you. Assalamualaikum. Goodbye.
Thank you, sir.
Okay, sir.
Thank you.
Yeah.